Hi, I am Adrian, and I've lived here for a year. It's very nice to go to one of my first meetups here in Amsterdam. So, thanks for coming. I'm going to talk about a thing called SoundSlice, which is a web-based sheet music engine, and it has a lot of really crazy hacks in it. So I'll show you a little peek under the covers of all these hacks, and hopefully you'll get something out of it. I realize that probably zero of you are building a sheet music product. Correct me if I'm wrong, but there are a lot of things that you can extract from this that you might be able to apply to your own project. This thing is called SoundSlice, soundslice.com, and that's my job, it's my company, that's how I pay the bills on Eerste Helmerstraat. And the reason for it is this. I'm a guitar player, and this is how I spend all my evenings when I'm not at JavaScript meetups. I sit in front of my computer with my guitar, and I try to figure out stuff, sometimes from YouTube videos, sometimes just from recordings. I just try to learn as much as I can and basically reverse engineer pieces of music that I like, learn little licks, learn tunes, blah, blah, blah. I play the style of music by Django Reinhardt, hence Django Web Framework. People know Django Reinhardt here? Yeah, this is a cultured bunch. Very nice. So this is how I spend all my time, and it is traditionally a really painful process. I would have all these things open in front of me. I have YouTube, I have a slow down software where you can pull in audio and slow it down so you can, as a musician, figure out what's happening. There's sites that show you how to play songs that are really badly designed. And then there's paper books. So I have all this in front of me, and it's just a really painful process. I wanted something that would put all of that together in one place. And so we as me and another guy, we made SoundSlice, the internet's finest music learning experience. I'll give you a quick demo of what that means. This is a piece of music on SoundSlice. It's all on the web, all in JavaScript. And when you first look at this, you might say, okay, that's no different than what a piano student would have seen in the year 1780. And that's actually true, because this language really hasn't changed for several hundreds of years. However, there are certain things that we can do to it because it's on the web and because it's in JavaScript and dynamic to make it a much better learning and practicing experience. The first thing you can do is hit play. And you can hear a real recording synced with the music. This is Django Reinhardt style music, by the way. If you're practicing along, you can just click on a bit of the notation, and it'll go to that moment in the audio. So if I click here, go over here. But I can also drag across a bit, and that'll loop it. It's going to get really annoying in a few seconds. But you can, this is something that I do as a musician all the time. I need to listen to something 50 times to really hear it, and I practice along with it, especially for fast stuff. But speaking of fast stuff, later here in this piece, let's say I want to work on that. I'll highlight it, and then down here in the lower left is a playback speed thing where you can slow it down without changing the pitch. Of course, there's some distortion because of the way physics works, stupid physics. But you can also speed it up in case you're feeling really cocky. So all of that is intended to work together, the looping, the navigation, the slowdown. But some people learn best visually. So if you look at the bottom right, there's this little icon you can click, and you see the fretboard of the guitar. It's basically, these are the 6 strings, and all those vertical lines are the frets on the instrument. When that is open, if you hit play, then the notes light up. So it's the guitar specifically is a very visual instrument, at least for me, the way I learn and I practice with it. So it can be nice to see where on the instrument the notes are happening. And if you're just learning a little piece of music or a lick, you can highlight it, and it'll show you in real time whatever notes are used in your selection. So it helps navigate where you are on the instrument. But it's not just for guitar. There's also a couple other views. There's a piano view. Everything is generated dynamically from the notation. So that's how to play it on piano. By the way, just in case some of you may not be guitarists, there's still time. But this stuff here hopefully makes sense to you. That's sheet music. It may not make sense, but you know what it is. This thing below it, those lines and those numbers, is called tablature. That's another notation for guitar players of fretted instruments, so bass, some other instruments as well, mandolin. That's a kind of a dumbed down version of notation. Each one of those lines represents a string, and the number is where to put your finger. So you don't need to know how to read music. You just have everything you need to know there, and you'll maybe be able to play. So that's called tablature. But some people frown upon tablature. They think it's for like children. So we have this thing called the mixer where you can just turn off the tab. So now I can feel super formal, and I'm just using music. Actually, I wouldn't be able to play this. I can't really read music that well. But if you are the opposite, you can turn off the notation and just see the tab. There's a little thing down here just in case you can't see. And then there's a sort of hybrid view where we have the stems from the notation along with the tablature, and then there's, of course, the whole shebang together. These are chord diagrams that show you where to put your hands on the guitar. And if you already know those, you can click this once and just see the names, or click it again and don't see them at all. So everything is being generated dynamically on the fly. And then over here, sometimes you have multiple recordings. So if you listen to this, it's 2 guitars. There's a boom, chink, boom, chink, rhythm guitar and a lead guitar. I happen to have the multi-tracks, so if I click on this, it'll just do the rhythm, so I can practice along with that, or vice versa, just the lead. And you can switch in real time, and it remembers where you are in the audio. And there's one called synthetic. I'll show you that later. In case you want to see things a little bit bigger, you can open up the settings here and make everything super big or super small. And it actually re-renders everything on the fly. So here's the entire piece of music, and as I drag that, everything's going to get smaller or bigger. That's a better way of seeing it like that. And then if you want to change something into a different key, this is getting a little bit into the weeds, but you just drag this slider and the notes all change into a different key, the chord symbols change, the tablature changes just by dragging this thing. So that's if you need to play with the singer and the singer has a limited range, or there are many reasons you might want to use that. So that's a quick demo of SoundSlice. There's a couple other things I want to show you though. It can also be synced with videos. So here's a silent movie clip that shows you a YouTube video that's synced. And in this case, I found 10 different YouTube performances that are synced with the same piece of music, wonder why the audio isn't working. But you can change in real time, just as I did with the audio, but you can change in the video and see how all these different performers approached the same part of the song. Because every performer plays something slightly differently. There's a Commodore 64 version, but it doesn't. The joke doesn't really work without audio. So a lot of the people who use the site do it with video, because you can not only hear the audio and see the notation, but seeing a performer can be very nice in learning something, especially for a physical thing like a guitar or piano as well, so you can see the fingerings. Oh no, beach ball! Any developers in the house? I'm just gonna force quit this thing. Chrome is being a bad thing. There we go. I'll open up localhost / presentation again. What was I on, 7? Okay. Now, everyone that I know who's a musician is learning things on the smartphone or tablet now. It's just much more convenient when you're sitting at your instrument to have a tablet or a smartphone instead of a laptop. But the problem is, if you have a piece of music that you want to learn and you look at it on a smartphone, this is going to happen. You're just going to have your music and the whole thing will shrink. And that really sucks. It's completely a pain. You have to futz around and zoom and pan the thing. And it's basically an image. That's what it is. If you buy a piece of sheet music, you get an image or a PDF. People think PDFs are sophisticated, but they're not. They're just images. So instead of that, with this sound slice thing, the notation actually wraps to fit your device. So on a small screen, it might look like this, but as I make the screen wider, the notation is actually responsive, which is what you want. You don't want it just to be like an image. You want it to know about the music and also know about the viewport that you're using. And there's a lot of intelligence built in. So for instance, here there's a repeat sign, but we know that if the repeat is at the end, we don't put it there, we turn it into a double bar line and the repeat sign goes here. There's dozens of little cases like that with these various silly things that happen in sheet music that are special cases when something's at the end, when something's in the middle, something's at the start. And all of that is just handled magically because it has to, because it's all done on the fly. So responsive sheet music. Now, let's actually talk about the technology. How does this work? Everything is basically an illusion on SoundSlice. This is on this version of it, I've highlighted the main area in a thick red border. And see, I'm using my scroll bar here. I'm scrolling up and down. So it looks like it's a web page. Well, it is a web page, but it looks like it's a long web page, when in fact it's just a canvas that's being redrawn every time you move the mouse. And over here there's a scroll bar on the right, which looks like a scroll bar, but that's just a div. And it has a scroll handler, so when I drag it, it feels like it's a web page, but it's just a stupid div with rounded corners, so it looks like a scroll bar. So the red border here shows you everything in there is a canvas. Now, just in case you haven't worked with Canvas, it's a HTML5 thing. It's just a canvas element. And you control it with JavaScript. You create it and you give it a height and width, and it's just a blank box. And then you have a JavaScript API, and there is probably a dozen or maybe more things you can do, but for SoundSlice I only use 4 things. Fill rect, that makes a rectangle and you tell it where you want the rectangle. Line 2, you can draw a line. Arc means draw a circle thing. And fill text, draw some text. And those are the only 4 primitives that I use to build this sheet music. And let's talk about how that works. At the very beginning, I have the sheet music in memory as a data structure, just some JSON, and it calculates all the spacing. It has to figure out how many, these things are called staves, how many staves are required to fit the whole piece of music, how many bars go on each stave. A bar is a measure of music, and that determines how much space is necessary. So the first thing it's done is, as in this version of the code, it just draws the lines. By the way, you can actually, everything else still works. It's kind of silly. Anyway, so that's the first thing that happens, and that's just using fill rect in Canvas. It's just draw a rectangle from here to here. There's nothing fancy about it. Then the rest of it is just these funny music characters, glyphs. Now, you probably are all Unicode. If not experts, then you're familiar with Unicode. Here's an interesting thing about sheet music glyphs, music glyphs. When the first desktop computer notation programs came out in the 80s, there were no standards. So there are music fonts, just like there are text fonts. And some fonts had the ampersand character representing the treble clef, and others had the capital S representing the treble clef, and others had the dollar sign representing the treble clef. And it was a huge mess. So you couldn't interoperate with these music fonts. And as of only about 2 years ago, there's a thing called the Standard Music Font Layout, SMUFFLE, which is a lovely named standard for sheet music. So now they've said Unicode code point blah 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 is the treble clef. So now people are starting to make their fonts all according to that standard. So anyway, on SoundSlice I use these 139 glyphs, and there's a free font that I use for this called Bravura, and it has all the stuff that I need. So there's nothing fancy. The font maker did all the hard work of drawing all that stuff. So I just have this font, and the first thing I do with the font is make it smaller, because there are, in this font, 2,550 glyphs. There's a lot of stuff in music. It includes all sorts of Asian characters that are used in Asian music, and all sorts of modern 20th century stuff. But for SoundSlice, I only need 139 of them. So I highly recommend this free service by Squirrel, where you give it a font file, and you tell it which characters you actually use and which ones you don't want, and it'll generate a new version of the font without the stuff that you don't need. So this was a huge bandwidth savings for me, because I only need to give my customers 139 glyphs, not 2,000. So that's a super nice thing. And even if you're not making a sheet music engine, you might consider this for a headline, a title of your page, where you use a font only for that, and you have complete control over the characters in there. You really don't need all the ennyes and umlauts or whatever you're not using, so you can strip all those out of your font and save your users some bandwidth. So once we have the sheet music font loaded, it's just a matter of drawing those glyphs. So that is just a note head glyph. Here's the white note head. Here's the whole note head. This is a natural sign. There's these numbers are part of it, the sharp, treble clef. All those are just, the hardest thing is just figuring out what the XY coordinate is, and just take from the music font, display treble clef here. So that's basically it. That's how it works. These note stems, the stem is this vertical line. Those are just fill rect. That's just a rectangle. That's not part of the font, because the height of it varies depending on where the note is. So that's all done on the fly. And this squiggly line here for an arpeggio is this is one glyph, that arrow, and this little squiggly is a small glyph that's repeated 5 or 6 times depending on how much space is taken. So it's all just those font glyphs put in the right places. And then for the core names, that's just normal font, obviously. Now, some of you may be wondering, why didn't you use SVG for this? See, at least one person is nodding his head. Here are the reasons. I'll go through them one at a time. Canvas is a low-level API. It just gives you a box of pixels, and you're expected to do everything on your own. You just say, from this pixel to this pixel, draw a line. And with SVG, you can have, it's a higher level abstraction. You can say, draw a curve. There's more. You can use programs like Illustrator to create them. There's a whole infrastructure around it. But Canvas is low level. So SVG is sort of better, isn't it? Well, no. Canvas is much faster precisely because of that. With SVG, the browser has to keep all of those elements in memory. Everything is a DOM element. But with Canvas, it's just a dumb bitmap. So as soon as you draw something on it, it forgets what you drew. It remembers only the pixels. It doesn't know that it's a line. It doesn't know that it's a font or anything, which has pluses and minuses. The plus is it's much faster. And it uses less memory because it only has to it only has to use the memory of however big your rectangle is times 4, the RGB values plus the alpha channel. Whereas for SVG, it has to have a DOM element for every single thing. And if you look, here I'll go back, if we had a DOM element for every single one of these things, this isn't that long of a piece of music, but this would have over 1,000 DOM elements, and that would be, maybe it would work for this because it's maybe a medium length, but some people on SoundSlice put in orchestral scores that are half an hour long and have 12 instruments, and if it were SVG, it would take down the internet if if someone tried to do that. So less memory use is a big plus. There's a downside to using Canvas, which is you can't assign events or any sort of animations to specific things, whereas I could do that with SVG. So with SVG, I could say, if this particular node has a mouse over, turn it red. Or if that node is clicked, turn it red. I can do that with Canvas, but I have to implement it basically from scratch. Do hit detection, which I've implemented, so it's okay, but it just was a little bit more work. If I had used SVG, I would have gotten that for free. It's a trade-off. Also for retina screens, high pixel density, Canvas, you need to do some extra stuff. You need to double everything, or you need to multiply everything by the device pixel ratio. It's all possible, but you need to spend 5 days Googling and going on Stack Overflow. Whereas with SVG, it just works. So that's a benefit of SVG too. So nothing is perfect. For my particular use case, Canvas was the way to go. Now, there's one thing I didn't show you yet, which is the synthetic player. Here's a piano piece, and if I press play, nice ragtime piece. Make it a little bigger. This is not a real recording. This is basically MIDI. It's not technically MIDI, but you can consider it MIDI-like. It's just synthetic. So it's being generated by the browser, which means I can, let's see, I'll go here. I can change the instrument. So over here I have 70 some instruments. What do you like? Banjo? Bass? Nah. So why on earth would someone actually want that? Because it sounds really bad, right? It turns out it is useful in some cases for learning if you want to slow something down really, really far. If it's synthetic, then you still get a perfect sound. But if you used a real recording, it would be distorted. It would have artifacts because of that pesky physics. And the other thing is it's completely precise and rhythmic, which is good if you want to practice perfect timing. I would argue it's not great because there's a lot of subtlety about timing that makes music human. But at any rate, that's the synthetic player. How does that work? Well, for all of those 70-some instruments, there's a separate MP3 file, and it looks like this. Let me zoom in here. And it's just every single note of the instrument, chromatically, for the entire range of the instrument, and it's maybe a 2-minute long MP3 for every instrument. So this works like CSS sprites, if you've ever used that technique, where the player knows for this note in this octave, that is 43.2 seconds into the file. So as we play, I'll go back to the synthetic player, it is in real time going to that moment in the MP3. So it's only one MP3 in memory, and but it works. Yeah, it needs to keep. So stupid. And the downside is, if you have a very long, an instrument that has a long sustain, like a violin or a horn instrument, it's limited to I think this is 3 seconds. That was my own limitation, just to conserve file size. But if you have a really long note on SoundSlice and you use the synth player, it will end after 3 seconds. So that's a downside. And in the future, I could synthesize the sound, but that's not really why people use SoundSlice. They use it more for the real audio, so this is good enough for my needs. So audio sprites. Now, offline. Here's an example of a video. My favorite living guitar player, Adrian, not just because we have the same first name. So we can loop the video, slow it down. But then, if we look down here at the bottom of the screen, there's this Save Offline button. And I won't press it yet, but if I open the Chrome DevTools, I can turn off the network. Maybe some of you don't know this yet. You can pretend like you're offline. And if I reload the page, it'll actually say you're offline. It won't show the Chrome generic thing. It'll have a pretty message, regardless of which page I go to on soundslice.com. And then, if I go back to having an internet connection and go back to my piece of music, I can then click that Save Offline thing at the bottom. And what happens when I click that? It'll download all the JavaScript, it'll download the video, download all the notation, and save it for offline use. So then if I go back offline and reload the page, everything still works. It's amazing. This is actually a website, you know? The video still plays, you can still loop it, you can still slow it down. Everything's working even though there's no internet connection. And then if you go to any other page on the site, it says you're offline, but these are the lessons that you've saved for offline usage. So the use case is you save a bunch of stuff for offline use, and then you come back to your browser without an internet connection. Maybe you're in your practice room or whatever, and you just have to remember, go to soundslice.com, and it'll tell you everything right there, everything that you've saved offline. Now, how the heck does that work? How many of you have used service workers? Yeah? Okay. This is the most exciting thing in web development, since Ajax. I'm 100% excited about this. It basically is a way of intercepting network requests by your web page. So you have a service worker. This talk is not about service workers, so this is going to be very fast, but you have a bit of JavaScript that sits between your web page and your browser, and it is capable of intercepting any request. So we can say, oh, the browser is requesting soundslice.com/blah blah blah.mp3. I'm going to check my local offline cache for that file, and if it's in there, I'll just serve that without even hitting the network. So it's sort of like your normal browser cache, except you have control over it, and you can do things with it based on JavaScript logic. It is amazing, and that's how this whole offline thing works with service workers. It is amazing, service workers. Now, I want to rant a little bit. I'm sure that all of you have heard this argument that programmers are very expensive and hardware is getting cheaper, so programmers therefore do not have to worry about optimization. Here's a blog post from several years ago that was cited by a lot of people. Hardware is cheap, programmers are expensive. You might have heard this, premature optimization is the root of all evil. But I would like to push back on that a little bit and say that in fact, lazily saying premature optimization is the root of all evil, that leads to a lot of bad code and a lot of bad products. And actually, if you want to think about this a different way, it's premature optimization is the root of all evil, but don't assume that all optimizations are premature. And I think it's similar to this minimum viable product thing that everyone's talking about. The problem with that is the definition of viable. Viable means that it has to be viable. It's not just some Google form. So it's the same with this. Premature optimization, you have to think what is premature and what is not. And with SoundSlice, there's a lot that I do for optimization that some people might say is premature, but I would say is definitely not premature. It makes it fast and it makes it perform well. And now I'll dive into the depths of hell. One of the things that's incredibly important is minimal redrawing. Make this a little bit bigger. I'll zoom in also. So when I hit play, you'll notice that two things happen, well, three things. You'll hear audio. Second thing is that line will be moving across the notes. And the third thing, maybe you didn't notice because it's a bit small on the screen, but these notes turn red. Let's have a look. So you see they turn red, okay? So because it's a canvas, I can't just say, if it were with SVG, I could say, for this element, turn it red, and then turn it back black. I can't do that because this is canvas, so I have to redraw the entire thing. Every time anything changes, remember that red rectangle, everything changes every time there's a change in the notation, which is including those red when the notes change to red. So therefore, I do a lot of hacks in the code such that I only redraw if I actually need to. So I'll do a snap of my fingers whenever a redraw actually happens. So it happens with the music because it knows what the music data is, and it knows that how long the note lasts, and it knows that nothing changes when the note hasn't changed from the last millisecond. So it only redraws, how many notes are here? 10, 20 times in this during that playback. Now, if you resize, it's going to redraw many, many, many times because when the viewport size changes, all bets are off, and everything needs to be recalculated. So that's the worst case. But generally, unless you're a web developer obsessed with responsive design, which we all do this all day long, right? You probably aren't going to change the width of your browser, so it's no problem. Here's something I believe strongly in. No JavaScript frameworks. No jQuery. Yeah! No jQuery, no React, no whatever the cool new thing, Vue.js, whatever. I just have my own utils.js. It just has this. A shortcut for get element by ID, whether something has a class, whether something, or add a class, remove class. Some things for JavaScript events. Get the offset of an element, the coordinates on the page, and then Ajax. There's no need to use jQuery unless you have a legacy user base who are stuck on older browsers and you can't afford to spend all the time worrying about browser inconsistencies. If you're willing to forget older IE versions, which I would say, given that Microsoft has officially discontinued IE, it's a safe argument to make. You don't really need jQuery. And you can just use the built-in DOM and JavaScript APIs. They're pretty consistent across browsers. Of course, we have one of the world-renowned experts on this, PPK, in the room. Pretty consistent, would you say that's fair to say?
No, fair.
Reasonably fair, okay. So utils.js, that's what works for me. People have asked me, oh, can you open source your utils.js? No, you're missing the point. You make your own utils.js, no framework. And I speak as someone who's made a framework, Django, and I know I've spent years of my life implementing features for some guy in some obscure part of the world who needs this obscure little thing. Okay, we'll add it to Django. You know, jQuery, React, all these frameworks, that's when you sign up to use a framework, you're getting all the baggage from anyone who's ever needed to use it. So just use what you need, and you'll be happy. So another big tip is to use request animation frame. How many of you have used this? Oh, okay, you guys are experts. Does anyone want to hear about this? Of course? Okay. Request animation frame, a very quick overview. Here's the typical problem. If you have an event on mouse move, if I move my mouse, it's going to get big because of the accessibility feature in OS X. But as I move my mouse, that happens hundreds of times per second. This on mouse move event, hundreds of times per second. How many times per second can your screen redraw? Probably maximum 60. So if you have an event that does some redrawing on mouse move, you're wasting resources because your limit is probably 60 times per second that the browser can actually draw. But this is getting called way more than 60 times per second. So it's a complete waste of time. The solution to that is to use this thing called request animation frame. An animation frame is a drawing of the frame, the page, by the browser. And this is just a very simple way of how to use it. Instead of doing this on mouse move redraw, you would have a little variable that keeps track of whether you're drawing. And then on mouse move, if you're not currently drawing, request an animation frame, or do this on the next animation frame, and then set drawing false, and then set drawing true. So basically that sets an upper limit at how often that'll get called, and the upper limit is perfect because it's built into your browser. When I added this change to SoundSlice, it was dramatically better. I wish I had saved some sort of numbers to be scientific about it, but I don't have them, but it was completely noticeable. I would recommend using it, again, not only for building a crazy sheet music site, but for anything where you have scrolling, anything where you have events that might happen more than the browser can actually render them. Request animation frame. It is, as they say, the most polite name for an API ever. I would like to request an animation frame. Another thing that I think a lot about is garbage collection in the browser. just in case you're not aware of how to do this, if you open up the Chrome DevTools, you see a ton of stuff. You can devote a career to becoming an expert in DevTools. But if you go to the memory area, you can hit this record button, do some stuff on your web page, and then hit stop, and then you'll see some statistics on what happened on your web page. And this is a timeline, and there's all sorts of things, but down here at the bottom is the memory usage. And you can see these jagged cliffs. It goes up, then it goes down, up, down, up, down. When it goes down, that is most likely a collection of garbage by your browser. So just in case you don't know garbage collection, anytime you instantiate a variable in JavaScript that's an array, an object or something, and then you no longer use it, it's still there in memory until the browser cleans it up. It's not like a lower level language like C where you have to do that yourself. That's the nice thing about these fancy high level languages, is the language does it for you. The not so nice thing is you have no control over when that happens. And sometimes it can take many milliseconds just for garbage collection to happen, and that actually could be seen by your users as a jitter or some slowness in the page. So you want to minimize garbage collection at all costs. And here are a couple tips that I have about that. The first thing is, whenever you have a temporary list or object, so the square brackets or the curly brackets, try to remove that. So I originally would have something like this: function do stuff, create a temporary list, blah, 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 and then return the temporary list. Instead of that, I have a cache of garbage lists, or arrays. Sorry, I come from Python, so I call them lists. Arrays. So whenever in my code base I have something that needs to do something to a temporary array, I pass in a dummy temporary array that is created when the page loads. And then set its length to 0, do whatever you need, and then return it. Does this sound crazy? Kind of is, right? But this has a noticeable difference in performance because it doesn't have to be garbage collected. You might think, well, setting the length to 0 is sort of the same thing as garbage collection. If that array is just full of numbers, then no, this is much faster. It's just a quirk of the JavaScript engines. Another thing to do is to use singletons whenever possible. So I have a fraction class in SoundSlice that's just a numerator and a denominator. So we have 1/4. Here I create two fractions. In a naive and a stupid implementation, it would be this. And it's stupid because every time you create a fraction, even though it's the same exact thing, it's allocating more memory, even though it's the same exact thing. Instead of that, I have a little cache of all the fractions, and it just checks the cache for whether that fraction has ever been created before. If so, just return that object. They're singletons. They don't have any state other than the numerator and denominator, so this is a memory savings. Another thing, whenever you sort, if you pass the function inline, that function is going to be defined at runtime every time that's called. Instead of doing that, and then therefore this needs to be garbage collected. Instead of doing that, just create a function that does your sorting, have it somewhere globally, and then pass it to your sort function. Therefore, this does not have to be recreated constantly. Am I going too fast? It's okay? Right? Caching happens all over the place in SoundSlice. The position of things, the viewport dimensions. There are many cases where I need to know the width of the browser, but of course that only changes when the user resizes it. So you can cache it. The dimensions of the glyphs, how wide is a treble clef, how tall is it, that only needs to be calculated once. There's no point in calculating it 10,000 times in a second, which is what would happen otherwise. Anything that's expensive cache the heck out of it. Also, there's this concept called JavaScript hidden classes. How many of you are familiar with this? Okay, cool. This is I'm excited to share this with you. Yeah! First service workers, now this. 1, 2. Okay. In the V8 engine, which is used by Chrome, it does some really heavy-duty black magic to make sure your JavaScript runs as fast as possible. One of the things that it does is it looks at your code's usage over time, while not just when the page loads, but while the user is using your page. And it keeps some statistics on all your classes and your objects and stuff. So for this example code, you've got a thing class and it just has one attribute, data equals 3. So let's say I create one, I set data to 5, I set it to 42. If you do that several, I don't know how many times, dozens or hundreds of times, V8 will say, oh, this is only ever an integer. Therefore, I can optimize it. And I can maybe store it in memory as an integer. I can use integer calculations, which are faster at the lower level. And I don't have to do all the high-level stuff. And it basically makes it into something like a C struct, if you're familiar with that. Something kind of like that. So that's really, really nice, and we get that for free because the genius browser developers have done that for us. But there's a catch. If you later in your code say c.data is hello, that changes the type. Of course, that's completely legal JavaScript, but then the hidden class, and that's this thing I was describing, it's called a hidden class. It'll say, oh no, we thought this was an integer, and now it can also be a string. Therefore, we can't optimize anymore. All bets are off. Optimizations stop now. And it doesn't run as fast as it can. So the lesson is, if you use classes like this, don't change the data type. Make it consistent for the entire session of the page. Does this make sense? Yeah, okay. This is a really crazy one that dates back to probably the 70s. Bit fields. So every note in SoundSlice is represented by this data structure, a note class. And it has many, many attributes, probably 30 or so. Whether it's a tie, that means whether it has a squiggly thing after it, whether it's accented, whether it has a heavy accent. And those are just Booleans. But here's the thing about JavaScript objects. They take 8 bytes in memory. Did you know that? That's insane. So even though it's just a Boolean, and even with that hidden class stuff that I just talked about, Booleans take 8 bytes of memory. Now, how much memory should a Boolean take? 1 bit, 1/8 of a byte. So this is 64 times too much space. There is a solution. It's really ugly and horrible, but it does the job. So the problem with that is not just conceptually that you're wasting memory, but it actually can be a problem because on SoundSlice, for a big piece of music, there might be 1,000 notes. And if 1,000 notes all have 30 attributes, all of which are 8 bytes, that adds up. So how do we fix that? With these crazy bit shift hacks. So instead of having a bunch of Boolean attributes, I just have one number called a bit field, initialized to 0. And that takes up only 8 bytes. And then if I want to access certain attributes like the tie, accent, heavy accent, I refer to 1 bit of that 8-byte thing. So I have 64. Actually, it's a little bit less than 64 because of JavaScript weirdness, but let's just call it 20 or 30. You can fit 20 or 30 Booleans inside of 1 8-byte number field in JavaScript. And the syntax for that is really ugly. you really should be using getters and setters for it, otherwise you will probably lose your sanity. Yes, so that's resulted in a huge memory savings for SoundSlice. I use Bit Fields quite a bit. And I feel like I'm my dad, who's a computer programmer from the punch card days. Like, yeah, tribute to dad. Now, the biggest performance tip is when it's slow and you don't know why, I just delete stuff and then see what happens. I actually do this quite a lot. If something was being a little pokey, a little bit slow, I'll make an educated guess as to what's doing it, and I'll just delete that. And actually, a lot of times, that has no effect. So it's in being scientific, quasi-scientific about it, that helped disprove some stuff, and it helped save me a lot of time, where I assumed that this was a problem, so instead of just jumping in and trying to optimize the code, I'll just delete it and see if it made any difference. How many of you use Google Closure Compiler? Couple, okay. I highly recommend it. It is a program that you run on your JavaScript and it compiles it. So we probably all know compilation stuff. But Closure Compiler goes above and beyond with something called advanced optimizations. So the SoundSlice code is 962K, just JavaScript. That's including comments. If I were to gzip that, it cuts it down substantially, but it's still very big. Compiled with just normal Closure Compiler, it brings it down to 343. If I gzip it, 99K. That's very good. But compiled tfei, what is that? What is compiled tfei? It's something called advanced optimizations with Google Closure Compiler. And what that does is a lot of black magic to your code to make it really, really compact. It renames all the variables to one character. It removes any code that is never used. It inlines, actually I have a slide, why am I trying to remember? It renames the variables, it removes dead code, things that are never used, it just deletes it. Inlines functions, so if something is just a one-liner, it'll take the code and just put it wherever it was used. And a really nice benefit that I hadn't expected until after I was using it was I can generate different versions of the code base by setting some global variables and then passing them to Closure Compiler. So there's an embedded version of SoundSlice, for example, that other companies use and embed in their own sites. And it doesn't need some of the stuff that soundslice.com needs. So I just have an if embed version in the code, and then Closure Compiler sees that, and it deletes that, and then because of the dead code elimination, it deletes all the other stuff that referred to it that wanted it to be there, and then it just makes it much, much smaller. It's a brilliant piece of software. And then finally, how do I test this crazy thing? I use PhantomJS, which basically does this for about 80 to 100 examples of sheet music, because there are so many edge cases. It takes screenshots and it compares them pixel by pixel to my baseline screenshots. Anytime I make a change to the notation renderer, I run this, and that's saved me many, many times. So if you're doing anything with generating graphics, or even for testing CSS, which is, a really it can be a hairy, scary thing to change CSS and not have any confidence about whether you've disrupted any part of your site. I highly recommend making screenshot tests. The downside is that even if one pixel changes, fail. So you have to write your tests in such a way that you either ignore that or step aside by only testing one part of your page. And I highly recommend, I use PhantomJS, which is headless. So this slide was actually a lie, because you don't actually see anything, it's headless. But it's very fast. And I'm happy to take questions about this. Yeah?
How do you fit a 64 byte physical bit in one byte? in the one character, how does it look in your console?
How do you fit 64 booleans in a number? You can access an individual bit using bit shifting. I'll go back.
I would be curious how it looks in the console basically.
Yeah, okay, this thing. These less than signs, that means shift off a bit or shift on a bit. Are you familiar with this? Yeah, okay. So that's how you do it.
It's not in the instrument,
It's actual, it's referring to actual bits. They do get converted to JavaScript numbers, but, so you might think, oh, it's you're losing the optimization, but the JavaScript engine is smart enough to see that it's only used there, so it keeps it small. Yeah, good question. Anything else? Yes?
With the synthetic music, how do you do chords?
How do you do chords with the synthetic player? You can do multiple at the same time. Yeah. It uses the Web Audio API, and you can schedule at very precisely, you can access the same audio file multiple times. Yeah. Who was first? In the black. Yeah.
How does the syncing work?
Oh, yeah, the syncing. Yeah, I didn't really show that, did I? Let me go to show you that. This is the little admin for if you have a SoundSlice account, you get this. This is called the sync editor. So it's you see the music, but you also see this thing on top. That is the waveform of the audio, and these are the sync points. I'll clear them though. So pretend I'm starting from scratch. There are a few different ways to do it. The easiest way is to listen to it and tap on the keyboard, or hit this button, add downbeat, or hit T on the keyboard on the downbeat. So I'll do it right now. I'll do the first. Okay, you get the idea. So it's manual. If I made a mistake, I can always move them around. And sometimes, with a very expressive performance, this is not good enough to have sync points on the bar lines. So you can go in, I'll zoom in a little bit, and move individual notes sync points. And it remembers that. It takes whatever the notation is from here and overlays it over the waveform. So you can sort of see it just by looking at it, whether that was right or whether it needs to move.
Have you ever attempted it automatically?
Yeah, I have attempted the automatic guessing. In theory, that is completely possible because you have the notation, you have the audio, but in practice, they're not always the same, and things like repeats confuse things. I think it would be possible, I just haven't done it. Yeah, good question. Yeah.
So font rendering is quite slow, right? Have you run into problems with that?
Yeah, definitely. That's the slowest. If you do the profiling in DevTools and you just sort by the time spent, it's the canvas fill text method. Yeah. So I've tried keeping a cache of the bitmap. I was not successful with it because for all the other things that run into the bitmap. For example, if I were to cache this black circle, sometimes I don't know, you can see the sub-pixel rendering. There's some problems. So over here, there's when they're at different vertical positions, see how they have different sub-pixel hinting, exactly. If I have a bitmap cache, you lose that, and it looks kind of Niet zo goed. Heel slecht. So that was the reason I stopped it. And I don't remember for sure, but it might have been just as slow also. So I'm still looking for a solution.
Using SVG instead of font?
Sorry?
Using SVG for the font instead of the font.
Using SVG for the font.
Or
It's way slower.
Sorry,
You have still the same problem.
same problem. Yeah, it has to render. Basically, what's the opposite of vectorizing? Rasterizing. Yeah, that's the slow thing. Yeah. Any other questions? There was one. Ah, yeah. Hey.
Do you use service workers for your own offline supports?
Yes. Yeah.
Safari or Holovaty?
Nah, Safari. Man, those guys.
Or you never found that for that?
Yeah, on Safari, you just don't see save offline.
I thought so, yeah.
That's the problem with service workers. Well, it's not the problem with service workers. It's the problem with Safari. Yeah, so far service workers are only supported in Chrome and Firefox. Edge is working on it. But Apple, they've said it's in their 5-year plan. I think that's all I've heard about it. Okay. Yes?
How do you make money on this?
How do I make money? Yeah, I didn't talk about that because it's not really technical. 3 ways. There's license the software to other companies. There are Zestig companies, 60-some companies who pay a monthly fee to use it, and they embed it on their own site in an iframe. These are music education sites that have video lessons, and previously their customers just saw a video, but now their customers see a video and the notation is synced. So it's like 1,000 times better learning experience. There's also a product for music teachers, and then there's a marketplace of music lessons where anyone can buy video lessons that we create. So it pays the bills for me and one other guy. Anything else? Yes?
My girlfriend sent me here because she likes to listen to music but how to transpose music to sheet music.
Ah, that is the holy grail.
There's no other problem.
How do we convert audio to perfect sheet music? That is an artificial intelligence problem. Many people are trying to do this. Nobody has done it. It works for some styles of music, for some instruments. Piano, people have had success with because the sound of a piano is very simple compared to other instruments. There's no vibrato. It's just ding, and then it decays. But a violin or even a guitar, there's vibrato, there's all sorts of other stuff. It's very difficult, and especially when you have, they call it polyphonic transcription. You have more than one instrument playing at the same time. There, again, physics, the overtones and harmonics overlap, so it's very difficult to tell which part is from what instrument. The human brain is very good at that, so in theory it is possible. Of course it's possible. I could do that. I'm a pretty good by ear learner. Just play something, I can tell you what the notes are. It's possible, but yeah.
For an individual musician, you need the sheet music and the sound slicer and the video, and then you can work with it.
The idea is some people learn best from looking at the notation. Some people learn best from the audio. Some people learn best from the video. Just throw it all in there. Some people might not use this, might use that. Yeah. Yes?
The publisher, are they actually delivering the highly structured information? Do you get read files, or what's the source of
What is the source of the data? When you have an account, you upload music notation data in a few different formats. There's a standard called Music XML that most notation programs will export that. It's sort of like the world of browsers. They're very inconsistent and buggy. So my Music XML importer is like 1,000 lines long. Just has to deal with all this old stuff. So yeah. That's
Okay,
it.
stepping in.
Okay.
You know, well, just to
Ja,
answer Greg.
dankjewel.
Yeah, of course. Maybe